Hello and welcome to our first Q&A session. Pranav, Yurong, Ben, thanks for joining us for some question and answers. We're seeing lots of great questions coming into the chat, so let's jump right in. This first question is for Pranav. So Pranav, while I was watching your talk, I was wondering what AR use cases can leverage edge computing?
Yeah, that's a great question. So pretty much like any sort of use case which requires compute-intensive ML operations, which cannot run on device, just because I mentioned that these devices are constrained devices and have low power envelope, so you cannot potentially run them on devices. So there's a strong need to offload the compute to an edge server, which has possibly GPU support and can give you a huge gains in compute latency. So any use case ranging from GANs to generation of avatars or any use case which requires computationally expensive ML models will require you to offload most of the compute. This is where edge servers can come in really, really handy.
Awesome. And so, Yurong, this next question is for you. What are the use cases for interactivities in video?
Yeah, this is a great question. So there have been many features around interactivity. So for example, we have those interactive stickers. We have those interactive polls, questions. We're also looking for more interesting features in this space that will help increase engagement with interactivity.
Awesome. And so, Ben, this next question is for you. What does scale mean for Arty, and how do you address scalability?
Thank you for this question. So this is an important topic for us as our architecture allocates expensive resources and the scale directly affects our costs. The main technical concern in scaling our platform is the high compute workloads for the rendering engines. That's obvious. So currently the architectural scalability and availability of the services are not limited, but availability is a costly attribute. So this is why this is an ongoing challenge for us. Some of the solutions we implemented are currently naive and will add to the platform's capabilities as more users are on our platform. The main scaling challenge we anticipate is the high cost in terms of unit economics. So when we scale for B2B, for example, we need to reduce our price. There are many solutions for this problem, technical, product, and business solutions. So in terms of the technical solutions, we'll examine different server allocating schemes, reducing bring-up times, and supporting multi-tenancy. Regarding non-technical aspects, we need to consider which graphics capabilities are used for our use cases and create different tiers and solutions for editing and presenting.
Awesome. Thanks, Ben. So, Pranav, back to you. This is a question from our audience. Do these edge servers support the same kind of latency for folks interacting from different continents, say one person from the West Coast and another one from India?
Yeah, this is an excellent question. And it really boils down to how you have actually allocated your edge servers. Now, in my talk, I mentioned that we have geographically distributed edge servers. Now, in this specific question, we're talking about a user in the West Coast in the US and another one in India. So the critical aspect here is that the two edge servers need to be as closest to these end users, which means that a user in the West Coast needs to have an edge server closer to him or her. And similarly, for a user in India, they need to have an edge server closest to them. That is basically allowing us to optimize for the last mile latency. Though the challenging bit here would be that given that these two users are geographically distant apart, there is still going to be some network latency which is going to be incurred between these two edge servers. But the good thing is that we have various compression algorithms which can allow us to optimize the amount of data being sent over the wire. And how we do that really is the critical thing here. And it could be a challenge as well because of this sort of geographical placement of these edge servers in a distributed location. It is really hard to quantify like what would be your P99 of the latency SLAs, but you can very well claim that you will be able to still have a seamless QoS for P50 or P70 of the users. And that's where the challenge lies. Like, hey, how do you place these edge servers in an optimal way for serving different categories or different sort of buckets of users distributed geographically across the globe? I hope that answers the question.
Yeah, great. Thank you, Pranav. So I have another question here. And this is from Yorong. So why do you use eMessage instead of other protocols like ID3?
Yeah, that's a great question as well. So we choose eMessage as a way to deliver time metadata for live due to its flexibility and compatibility with our infra system. It don't really have a strong preference over specific protocols, more like which one kind of suit best for the existing system.
Awesome. Yeah, I think that makes sense. So I think what you're saying is that the protocol doesn't really matter. It's about the interactivity itself and the features that we're building on top of it.
Correct.
Cool, cool. So we actually got another question in the comments for Pranav. Since we're just talking about latency, what would you say is the target for acceptable end-to-end latency from user to cloud or other users, from the user to the cloud to other users for XR use cases in order for them to receive mass adoption?
Yeah, this is again an excellent question. And I would say this is an area where a lot of data engineering and data analysis can come in really handy. So far, our analysis is based off of the data which we have been able to generate from WhatsApp calls or Messenger calls, where people are geographically distributed in a one-to-one call setting. And the P70 of those numbers look like close to 400 millisecond. But now the interesting bit there is that in a Messenger call or a 2D video call, we are just sending RGB frames across the two users. And in this case, in AR, we are potentially transmitting RGB and also depth because this is an immersive environment. And we do want to make sure that we are catering to the low latency SLAs. So even if we set the benchmark as 400 milliseconds for an end-to-end sort of calling session, we do want to go lower than that so that any sort of interaction you have with shared objects in an AR space is reflected in real time. And hence, we have kept our goals to be pretty aggressive, and 200 milliseconds is what we claim is a plausible experience. But anything below 400 is going to be acceptable, is what the nomenclature looks like as of today. But again, there are a lot of optimizations available, and with better networks coming in and 5G and 6G networks over the next few years, that will allow us to cater to even more lower latencies.
Awesome. Thank you. Okay. So Ben, going back to you, what are the main use cases for Arty? Can you tell us a little bit more about that?
Yeah, sure. Thanks. So, well, we have broadcast customers as well as creators using our system. Currently, we focus on enterprise presentations and use cases like presentations for virtual events or CEO presentations, sales presentations, marketing, as well as training presentations, for example, for assembly workers. We believe that making these presentations engaging and memorable will yield highest value for our customers. But regarding the risk in this focus is that not all salespeople, for example, and presentation designers are familiar with or willing to go into learning AR tools.
Awesome. Thanks, Ben. And can you tell us what the main causes are of the platform's latency?
Sure. So our latency is roughly 200 milliseconds. And of course, latency is an important topic when discussing live video streaming and real-time graphics. So since we have peer-to-peer communication between the client side and the Unreal engines, it's about 60 milliseconds per direction. So that's to 120 milliseconds. To minimize this latency contribution, we allocate the rendering engines appropriately so the performance may depend on your location. In addition to that, we buffer around 2 frames, so that's about 60 milliseconds addition to that. There's generally no significant load on the client-side system to achieve this latency, unless additional encoding and bandwidth are used, for example, while screen sharing in our platform. The effects of this latency are negligible for our use cases. Of course, it's noticeable when monitoring the video, but the presenter's focus is usually on the content and the AR playground.
Awesome. Thanks, Ben. Okay, we have lots of questions coming in the chat. So I'm going to try to pick just another question to ask here. Pranav, we've got a few coming in for you. Which protocol is used for RTC transport?
Yeah, this is, I think, a really, really important question. And the reason I say that is because that affects our overall latency SLAs. There is, first of all, no right answer to that, but I would claim that we have started our explorations with WebRTC as the first choice, but there are certain constraints to that. For example, how do you stream depth data at scale? So we've been sort of exploring WebRTC, but there are other options like Quick and Rush. And we've also been sort of like looking into our custom protocols as well, which allows us to stream like, 3D data instead of like just 2D RGB frames, which meet our latency SLAs. So the short answer is that there's no perfect protocol for lower latency here for RTC transport, but we can start off the exploration with WebRTC as like the de facto standard, which is available in the market, and then also analyze the trade-offs with like Rush and Quick-based protocols.
Awesome. Thanks, Pranav. Okay, Jurong, this next question is for you. The question is, for real-time interaction setup, is it setting up the software and hardware encoder settings, streaming via HLS, RTMP, or something else? The question didn't have a name attached, so we might all, since this is about interactivity and like quickly streaming video, if you have another answer to this, feel free to jump in.
Cool. I mean, this is a very interesting question. So for the real-time interaction setup, we mostly talk about how the broadcasters can interact with their viewers in a real-time manner. In this case, of course, we want to achieve a very low end-to-end latency for this case. And we are not, in most of our protocols, we don't really use HLS and RTMP in our Facebook infrastructure. But the goal is to leverage whatever the capability that we have. We currently use the low latency dash that we developed it as a proprietary protocol internally to achieve this capability. But overall, I mean, the latency is one critical factor to deliver a real-time interaction framework for our system. So yeah, I'm not sure whether I answered that question kind of directly, but I mean, the infra setup is one thing. The interactivity setup is another thing on top of our existing infrastructure.
Awesome. Thanks, Jurong. And kind of like adding on to that question, one person wanted to know, like, which protocol is Meta using for low latency? Or is it a custom ingest or egress setup from origin site to FB? So this one, since it's low latency is involved, we might be able to get some answers from you, Jurong, or maybe there's an AR specific answer. Pranav, I know you were talking a little bit on the protocols as well. So this is like a shared question.
Yeah, I can go first. I mean, I can go from the live side, and we are using protocol, which is, I mean, internally we call it video protocol for video protocol, and it's specifically using Quick. I mean, delivering the video through Quick. So this in other words, we are using our customized protocol, but we are actually standardizing this protocol with the community for the moment.
Awesome. Yeah. And Pranav, does that sound aligned with like how we're thinking of ultra low latency for AR and the metaverse?
Yeah, I think so. Live streaming scenarios and ultra low latency scenarios in AR are slightly different. Like in case of a broadcast live stream, you could still like start the live stream and have your recipients receive that data like a second later or so. But with AR scenarios, which are ultra low latency, you want those interactions to look like super real time. So we have to go target like close to 200 to 300 milliseconds SLAs, which is not achievable with some of these de facto live stream protocols. And hence we use Rush-based protocols or like WebRTC-based protocols, and also like sort of working on our custom protocols as well to sort of meet these latency SLAs. Yeah, there are different knobs which you could tune in WebRTC, for example, to have like a plausible experience. For example, I mentioned briefly about jitter buffers, play out delays, so that the experience is not laggy. There are a bunch of other optimizations you could do on the encoding and decoding side as well, on the hardware itself to gain some of the performance improvements. There are like some of the optimizations, including zero copy, especially when you are copying data from like CPU to GPU memory, specifically in AR cases. So that allows you to get some of the lower latency optimizations met as well. So yeah, it's a combination of a bunch of operations, but yeah, choice of the transport is the key decision maker. And WebRTC and Rush are probably like the strongest candidates as of now.
Awesome, thanks. Okay, let's see. There's some more questions in the chat. Okay, I think one person had a follow-up question, Pranav, about like SRT. Have you considered using SRT previously?
So we briefly did. I think it has some really good constructs and sort of like paradigms available to meet those lower latency SLAs. But at the same time, we need to like stream depth data as well for 3D immersive experience. So there are like a bunch of things which we may need to customize to support like sending depth buffers as well, which SRT may not support natively.
Awesome, thank you. Okay, so this question's for Ben. Typical video codecs, HEVC, H.264, without multi-view stereo profile, don't support depth or 3D. Could you explain how graphics with depth have been inserted into the compressed 2D video frames?
Sure. So we don't exactly transmit the depth information. I covered this in my lecture. So what we do is we send only the tracking information to the backend, and we calculate the 3D position on the backend, and we render just the composite. And sending this back to the client side, we then create the composite of the video and the graphics overlay. And this will be in the correct position. I hope this answers the question.
Awesome. Thank you. Thank you so much, everyone, for joining us for the Q&A. Ben, Jurong, Pranav, thank you all so much for answering the questions. There's a bunch more questions in the chat, so please do head there and check them out and respond to folks. Now we will resume our presentation.